Aloha class, here we go. We're on section 3.3 now, rules for differentiation. So now, if you've been tired of doing that long, crazy, long way of doing these problems, we kind of learned some shortcuts. So it's a pretty sweet lesson. Here we go. We're going to try to get through the whole thing fairly quickly. We're going to go for a half hour here. There's going to be a lot to take in, so make sure you pause that bad boy if something's not making sense or you need to rewind, okay? Topics from the AP exam. Okay, topic 2.5, applying the power rule. We learned the power rule for finding the derivative, which is to calculate derivatives of familiar functions, okay? We're also going to do 2.6, which are some derivative rules for constant, sum, difference, and what we call the constant multiple. That objective, calculate derivatives of familiar functions. Sounds kind of similar. We're not going to get into much trig yet, those crazy bad boys. But we are going to go into the product rule, which is a super cool shortcut way of doing some derivatives where we could do them a really long way, or we kind of have a shortcut objective there. Calculate derivatives of products and quotients of differentiable functions. And 2.9, the quotient rule. Okay, same learning objective as the next. All right, here we go. We're going to get started here. Rules for differentiation. And what I want you guys to do is you are going to hit pause, and I want you to hit pause, and what I want you to do is this warm up here. Let me hit my pen, okay? I want you to do the warm up right there. Hit pause, hit that, and then I'm going to have the answer when you re-hit play. Okay, so I'm going to hit this bad boy right here, and it's going to give us the answer, okay, to what I just asked you to do. And we're just going to look at a couple of things here, okay? If you look very carefully right here, all right, we have the graph of y right there. Ooh, snap. That might not have been on that sheet, okay? And what we wanted you to do is do the derivative. So if this wasn't on your sheet, here we go. We'll just do this warm-up kind of together. I'm kind of remembering here. Let's see if it was. I don't think it was, class. Let's check it out. Oh, it was. Sweet. Never mind. What am I talking about? All right, here we go. And you wanted to graph dy dx, so you should have been able to do this on your own, okay? And we're going to graph dy dx. Well, you want to look for some things. So hopefully you guys did this. You said, oh, snap, I should try to find horizontal tangents. There's one right there, so you graph it at 0. There's another horizontal tangent right there, so you graph that at 0. And then the rest of it, hey, since this is rising, or positive slopes, that's why the derivative is positive. All the slopes from here to here are negative, and then it ends up back positive. Hopefully that was okay. Class, if it's not, please make sure you come in for help. And then they asked me to use the alternate form right here of the definition of the derivative. Okay, and all your work is right there. You get 0 over x minus c, which is 0. The slope at any value of y equals 5 is 0. And we should have known that, right? Because that's a horizontal line. And a horizontal line is going to have a tangent slope of 0 throughout that entire domain. Okay, let's get back now, okay, to the good fun stuff right here. Boom, okay? And let's go ahead and use that up. A lot of rules we're going to go through here, okay? So I'm probably going to be going a little fast. I apologize. Make sure you guys, I guess I should do this. Drum roll, please. And now the moment you've all been waiting for. Okay, I guess I'm supposed to do that. I apologize. I'm a little wacko here today. All right, rule 1. The derivative of a constant is equal to 0. We just did that in the warm-up above. Right? Anytime you take the derivative of a constant, our answer is always going to be 0. For example, okay, f of x is equal to 5. Find f prime of x. Booyah, I can just say f prime of x is equal to 0. Boom, done. I don't even have to show any work. No more using that crazy formula. Sweet. But you never want to lose, or you never want to forget the original definition of the derivative or the alternate definition of the derivative, even though we're not going to be doing it the long way anymore. Okay, see, so that's it. Let's keep on moving. Okay, we're going to roll right here. Okay, we're going to do something real cool right now called the power rule. Okay, ooh, I'm supposed to be, come on now. It's a crazy little thing. Okay, boom, power rule. Okay, now, let's say, we'll just get right into this bad boy, okay? But here's our power rule. If we take the derivative, okay, where your base is x, so like x to the third, x to the fourth, all we do is drop that exponent down and we subtract 1. Watch how super cool this is. Oh my gosh, could you imagine doing this x to the fifth the long way? I taught you guys that little Pascal's triangle, correct? Hopefully you'll always remember it. okay, you would have to go all the way down there to what? 1, 5, 10. 1, 5, that's 10. Ooh, that's 10 again, that's 5. You would have to use all of those coefficients. Or instead, finding the derivative, I could just do a little drop that 5, x to the 5 minus 1, which is 5x to the 4th. Mr. Tanaka, you made me do that the long way? Boom. That's all right. From here on out, you can use that shortcut. That's all you have to do, class, to do the power rule, to do derivatives from here on out. Okay? Let's go ahead and we'll zoom this up a little bit more. I'm going to erase once again. The comment was as if we're going fast. Make sure you hit pause. Okay, boom, boom. Oh my goodness, what's going on? There we go. Boom, boom. All right, here we go. Now, the key to using the power rule is to get comfortable using exponential rules to write a function as a power of x. So if you see this bad boy right here, what should I do? Well, I should rewrite it first, okay? So you always want to rewrite these guys. Okay, if it's written in radical form, we rewrite it with a rational exponent, which is x to the 2/3. Then that's like, oh snap, that's a base of x. Okay, I've got a little exponent right there. I can use the power rule for that, dude. So that'd be f prime of x is equal to 2/3 x to the, what the heck is 2/3 minus 1? Well, that'd be 2/3 minus 3/3. Oh, I can handle that. That's 2/3 x to the negative 1/3. Booyah. And we like negative exponents in AP Calc. Got it, guys? So you can leave it like that. Don't try to get crazy, show off your skills by doing some putting that guy in the bottom or anything like that. Okay, here we go. Ooh, that's 1 over x to the 4th. Well, I need it to be written as x to some power and able to use this power rule. So I'm going to rewrite f of x equals x to the negative 4. Then check this out. I can use the power rule. Come on down, big guy. Negative 4x to the, ooh, if I subtract 1, that'd be negative 4 minus 1. That'd be to the negative 5. Once again, we like negative exponents. You don't have to rewrite that guy. Okay? Pause that bad boy if you need a little bit of time because we are rolling. All right, here we go. The constant multiple rule. What's this guy talking about? Well, all it's talking about is if you have some function u and you have a constant, you can pull that constant out. I think this one will look a little bit better if we kind of do an example here. And I'm going to look to make sure I'm looking at this right. My eyes are kind of going here on this screen. So what is that? That is negative 3x to the 5th. Okay. So what they're saying is you can do this, and you don't necessarily have to, okay? Here's a little bit different notation for this one, okay? So what's dy dx? You know how I could rewrite that? I could write that as d. What is y? Y is negative 3x to the 5th dx. Okay, so I'm going to take the derivative of this guy right here. And what this little constant multiple rule, and you don't necessarily have to do this, and I'll show you why. You can take out the negative 3, okay? And then you're going to take the derivative of x to the 5th. Right? And how do I take the derivative of x to the 5th? Well, that is a power rule, which is 5x to the 4th. Now, if I simplify that, 15x to the 4th. Booyah, done. Okay, and what some students will say, well, Mr. Tanaka, couldn't I go back to this step right here, just drop that 5 and multiply those two guys? You sure could, because negative 3 times 5 gives me negative 15, and then subtract 1x to the 4th. So that's something you could do, class. You don't have to. I think most students are going to buy into not like using this rule, okay, because it kind of just happens on its own. For example, this one right here, if you notice, I have kind of a 4/5, right, class? I definitely want to rewrite this problem. G of x would be equal to, what would that be? That'd be 4/5 x to the negative 3. I think that's a 3, you guys. I apologize if it's not adjusted, if it's not. Okay, the eyes are going when you get old. Okay, the derivative. Well, that's just a power rule, right? That 4/5 is like a constant, so that's going to stay there. I could pull it out if I wanted to, okay? Drop that 3, I get a negative 12/5 x to the negative 4th. Boom. Okay, remember, I'm kind of going through these quick. I think I made a mistake in that 2-3 video, just a short one. Please come to class always and let me know if I'm making any mistakes and where they occur so we can kind of edit some of these videos, okay? All right, rolling. I mean, we are just rolling. Sum and difference rule. It's kind of like the limit rule, right? Where we do the limit of a sum is the sum of the limit. Same thing, derivatives, okay? And I'm going to do these all the long way one time, okay? Here we go. We have y equals x to the 3rd minus 6x squared plus 2x plus 3, okay? So here's kind of the long way of doing this one. dy dx. Okay, let's take the derivative of y with respect to x. So another way I could write this is like this. Okay, and I'm just doing it this way, you guys, to show how I'm using the rule. Okay, right? Anybody that goes to high-level math, we like to be able to show all of this work. Okay, now what I could do now is I could share that derivative with each and every one of these guys, right? That's what I could do for each and every one of these. Minus, oh snap, there it went, class. I apologize. I'm going to have to get back and using my pen here. Okay, here it goes. I apologize again, but I got to do it. Minus 6. Okay, and then we're going to take, or I should say, see, I already got flustered. Then we're going to take the derivative of 6x squared, okay, plus, and then we're going to do, ooh, let's hide that bad boy. It's messing me up. Then we're going to go plus d dx of 2x plus the derivative of 3. Okay, so what would that bad boy look like? We just take the derivative of each one of these guys using our power rule. That'd be 3x squared minus, right, that 6 is a constant, drop that 2, we get 12x, right? My next one is the derivative of 2x, which is a power rule, which is you drop that 1, you subtract, right? We're going to get an x to the 0. Anything to the 0 is 1, and the derivative of a constant is 0. Okay, now yes, you are 100% correct. You guys are saying, Mr. Tanaka, you are getting cray-cray. So what could you do instead? Well, hey, let's just find the derivative of that real quickly all at one time. Y prime is equal to, you can, yes, just go 3x squared minus 12x plus 2. Booyah, I am done, and I didn't have to write it all separately. And you know what, class? You don't have to. That is 100% acceptable. We just want you to know that if you have a sum or difference, you can just take the derivative of each one of those bad boys, okay? You do not have to write each one over and over again. All right, boom. Let's go to the next one. Once again, challenge yourself, class. And if you're feeling really good about this stuff, hit pause and try these bad boys, okay? Now, example 8, find the equation of a tangent line. Oh, snap. Find the equation of the tangent line. What's the very first thing I should write down? Y minus y1 equals m times the quantity x minus x1. I don't know about you, but I like to fill in everything I know right away before I even get started. And you know what? It's saying at x equals 2. Well, I could find the y value for that by plugging that 2 into the original equation. And if I plug that 2 into the original equation, I get 25. Right, class? That's plugging that 2 into our original graph. So I could already get some points on my next test by filling this stuff in. Okay? Now, if you notice, I left that blank. Okay, why did I leave that blank? Because I have to find it. How do I find it? Well, it's the tangent line. What does that mean? Tangent line means, hey, I've got to find the derivative. So let's find the derivative of that bad boy. And yes, it's all just a power rule. Drop that 3. We got a 12. Subtract 1. That'd be x squared minus 6. And that 5 becomes a 0. Okay, so now I want to find what the tangent line's slope is at 2. So that means I'm just going to plug a 2. What is it? 2. Oh, snap. My hand kind of hits this thing, you guys. I apologize. So that's 12. 2 squared minus 6, right? And so if I do all that math I kind of did earlier here, we get an answer of 42. So I take that bad boy, that's the slope of the tangent line at that point, so I can plug it in right there, and I get a 42. And you know what's awesome in this class? I let you leave your answer like that, okay? Here we go. We're rolling. All right, let's see, where are we at here? Boom, there's just some problems for you guys to practice. 9, we have 10. I'm going to let you go ahead and do those. Hit pause, do those bad boys, and then they're going to come up right away. I'm going to give you a hint about this one right here. Okay, what I want you to do with this one right here when you get to it is I want you to do a little foil. First outside, inside, last. Okay, and then do it, because there's kind of some multiplication going on right there. And so I can't really find the derivative of that bad boy yet. We got a trick to do that one a different way, but see if you can do that right now. Okay, class? All right, there we go. There are our answers. Here we go. You had to rewrite that bad boy first, right? Boom. Okay. And then you go ahead and you just use your power rules. There's a lot of acceptable answers because there's a lot of simplifying you can do. I would accept all of those. Remember, in example 10, the most important thing was you rewrite that, then it's just a quick little power rule. Okay, you guys? Here we go. I'm going to I might cut this video a little short here so I can reboot and use my pen because I've noticed my handwriting's getting a little crazy. I think I can get through this stuff though, okay? Here's just all notation. Make sure you're familiar with all of those different ways that we write derivative. First derivative, second derivative, third derivative, fourth. When we get to 4 and bigger, we put that little fourth derivative, that number 4 up there in like little parentheses. Okay, you guys, we use this notation a lot. We will use this notation. Make sure you're familiar with all those guys, okay? And try to use them. Try to like mix it up from time to time. Okay, ooh, I'm showing answers. Oh, snap. Let's go back to that, okay? I think we can get through this stuff. Let's take a look at it. Example 11, you guys, that'll be a piece of cake. I guess just be careful. That says, oh, snap. That says define the fourth derivative. Boom. That means you got to go first, second, third, fourth. Do that right now. Hit pause because I'm going to hit the answer up here in a moment. And then be careful. Example 12 does it a little bit differently. They give you the fourth derivative and they just want you to find the fifth derivative. Hit pause because after you hit play again, the answers are magically going to appear. Booyah! There it is. Find the derivative, the fourth derivative, which means you got to find the first, the second, the third, the fourth, and get used to that notation. I bet you got that answer, which means you're on fire. All right, here we go. Example 12. Once again, you just have to be careful. Okay, let's rewrite that bad boy. That is the fourth derivative. So you just have to find one more, and that's your fifth derivative. How about it? All right, class, I'm going to reboot this bad boy so I don't have to use this pen since it's getting a little crazy on me. All right, so I'm going to do this 3-3 into 2 videos. I will see you soon.